Okay, so this is 3.3. We're going to transform some quadratic graphs. This is a flipped class lesson, meaning that you should be doing this at home, writing notes in your notebook, then coming to class and working on these questions and getting assistance on them. So you're getting more time in class to actually do your work rather than to spend your class time learning and then being frustrated at home trying to work. So before we start off, we need to remind ourselves exactly what the y equals x squared graph looks like. So I'm going to call that just your basic quadratic graph. When you graph that, you notice that you get a very standard graph. Something like that. It's a parabola. It's opening upwards. We notice that our vertex is at 0, 0. It's right at the origin of the graph. And it comes through and it goes through 1 and 1 and negative 1 and negative 1. And it just goes upwards in a nice uniform motion. What we're going to do is we're going to experiment with what happens when we do different things to this graph. So rather than have y equals x squared, we're going to try y equals x squared, and then we're going to add a number. So we're going to do, let's say, y equals x squared plus 1. We're going to see what happens when we have y equals x squared plus 1. If you put that in your calculator, y equals x squared plus 1, you'll notice that your vertex has now moved here, and it goes up like that. It's still the same shape. The shape is just a little bit above the old shape, the basic graph. Now we're going to try what happens if we do a negative. So what happens if we try y equals x squared minus 1 rather than plus 1? If we do this and we put it in our calculator and we graph it, which is how I've been getting these graphs, I notice that my vertex is now down here at minus 1, and I've created the same graph as before. It's just a little bit below my original basic y equals x squared graph. So what does this mean about the letter q? So when we add a letter q to the end of a x squared graph, what it's doing is it's vertically translating your graph. So vertical translation means the graph is moving up or down. So the q value moves the graph up and down. And we'll notice that when it was plus 1, it went up. When it was minus 1, it went down. If I had done plus 2, then the graph would have gone 2 up. And if I had done minus 2, then the graph would have gone 2 down. And a good point of reference is always the vertex. So if you look at the vertex, you'll see that it went 1 up, and then it went 1 down. So a positive means up. A negative means down. All right, let's try this again, but we are going to, this is a nice little page that demonstrates exactly what we just said and learned. So it's a nice page to look at if you need to look at your notes. We're going to try another experiment. So again, we're going to start with our basic graph. Our basic graph of y equals x squared. The origin is the vertex. It goes up. It goes up. And we have a nice little upward facing parabola. I call that my basic graph. So in this case, notice that they put y equals x and then minus p. So instead of having a plus q, we have a minus p, and it's inside the brackets. So that changes things a little bit. When you're putting it in your calculator, when we go to do our experiments, make sure that you definitely use brackets. So in your calculator, you're going to want to put y1 equals, and then bracket x, and let's try -1, and then square it. So go ahead, put that in your calculator, and you should notice that the graph that you get is the same graph as the basic graph, it's just moved a little bit to the side. So that blue graph that I've put in, that was y equals x minus 1 squared. Now we're going to try it again, but instead of minus, we're going to put in plus. So we're going to graph it. We're going to try y equals x plus 1 squared. And we're going to graph that in our calculator, and we're going to notice that our vertex is now over at -1, and it looks the exact same as the other two. It's just shifted to the left a little bit. So if we look at these things, we need to decide what happens when we have this minus p in here. What's going on when we do that? So when we do this thing right here, what's that p-value doing to my graph? Well, if you look, you can tell that it shifted it 1 to the right, and then it shifted it 1 to the left, depending on if it was plus or minus. So the p-value shifts it left and right. Again, we call this a horizontal translation because it's going left or right. But we can just say it shifts it. P-value shifts left or right. Now this one's a little bit tricky because that minus sign kind of screws things up for us. So when we see a minus, so for instance, y equals x minus 1 like that, if we visually see it like that, that means it's right. So it's going to move to the right. However, the actual p-value that we've chosen is positive. So the p-value there is 1. It's not -1. And the reason why is because this negative sign right here matches up with this negative sign in our little formula. Meaning that the number 1 matches up with the p. So our p-value actually is 1. It's not -1. But in our formula, when we see -1, that means we're shifting to the right. If you see something like this, y equals x plus 1 squared, and you see a positive, that means you're going to the left. It also means that your p-value is actually negative. Because the only way we could have changed that minus sign in our formula to become a plus sign is if the p actually was negative. Because minusing -1 would be like adding 1. That can be kind of tricky. We'll do a lot of practice with that. Your practice book that has a lot of practice on that. So it's important that you do it over and over and over again. Again, here is a nice little slide demonstrating what we just learned, that the p-value horizontally translates things left and right. Our last one that we're going to do is called the a value. And what the a value is doing is it's actually multiplying by the x squared. So we always start off with our basic one. Y equals x squared. Now, a can do a lot of things. But the fact that they chose the letter a is not a coincidence. Where have we seen the letter A before? Well, we've seen it in something that we call general form, which we learned in 3.1. And we learned that that A value, it makes our graph narrower, it makes it wider, it can even flip our graph over and upside down. This A value and this A value, they do the same thing. That's why it's not a coincidence that they've called them both A, while they called the other ones P and Q were brand new letters to us. Just to prove that it does the same thing, we're going to try and pick an A value of -1. So we're going to say y equals -1 times x squared. And if you graph that, you'll notice that your graph is now upside down because a negative value flips your graph. Other things that A value can do. If you have a decimal that's in between 0 and 1 or 0 and -1, it makes your graph wider. So if you were to go and graph y equals 0.5 x squared, so A is 0.5, and you graph that, you should notice you get a graph that is wider. It's almost smushed down, so it's a little bit wider than our original graph. Lastly, if you chose an A value that was bigger than 1, so for instance y equals 2x squared, you would notice that your graph actually gets skinnier. Kind of like that black one that I just did there. And the same thing works if it's negative. So if it had been negative 0.5, it would have got wider, but it just would have been facing downwards. And if it was -2, then it would have been narrower, but facing downwards because it was negative. So what is true for all graphs? Well, for all these graphs, what's true is a negative A value flips the graph. Now, flip isn't the correct mathematical term. The correct mathematical term would be a reflection about the x-axis. So it reflects down into the other side. But I like to use the word flip because it gets the point across. So a negative A value, flips the graph. If the A value is less than 1, but greater than -1, so it's a decimal of some sort, we get wider. If A is either a lot smaller than -1, or if it's bigger than +1, we get narrower. The closer to 0 you get, the wider your graph. The further away from 0 you get, the narrower your graph. Again, here's a couple slides just demonstrating that. So this is showing the wider, skinnier version, and then it's showing that it actually works for flipping as well. Okay, we've learned 3 different transformations. We call those letters A, P, and Q. We can combine them all and write them like this, and this is called standard form. So standard form is when it's written in the format y equals A, and then x minus p in brackets, squared plus q, where A can reflect it, so it can reflect, or it could stretch it or smush it, so it can make it wider or narrower, That says widen or narrow. Our p-value tells us if we're going left or right. And our q-value tells us if we're going up or down. Now, something neat about this form, standard form, is that it is also called vertex form. And the reason why it's called vertex form is the p-value and the q-value actually tell you where your vertex has moved to. You'll notice if you look back at your slides where A was doing all that flipping, you notice that the vertex never moved. The vertex was always still right there at 0, 0. The only way that the vertex moved was when we were doing horizontal translations and vertical translations. We can then take that information and understand that our vertex will move the same way that P and Q are. So your vertex actually is P, Q. This also helps us find our axis of symmetry, because our axis of symmetry is always the x value of your vertex. So that means your axis of symmetry is just your p value. All right, let's try a question. So, match each equation to a graph below. So we're going to look at A, B, C, and D, and we're going to try to match it to the graphs on the right. We're going to start off with A. So remember, your basic graph always looks like that. And then depending on what A, P, and Q are, depends how things move. I'm going to write out my general form on the top just so I remember. There we go. So I look at this first one, and I notice that it's a negative A. So I know that I'm looking for a graph that will be face down. So I've moved into a face down graph. I then look at my p-value. I notice that it's +1. Because it's plus, I'm moving left. So I'm looking for a graph that is now upside down and to the left a bit. And then I look at my q value, and I notice that it's -2, which means I've gone down. So I'm looking for a graph that has gone to the left, it has moved down, and it's also facing downwards. Now your guys' graphs are probably pretty crappy, just like mine, and you're going to have a hard time reading them. So I'm going to draw in the axes for you. So that's an axis, that's an axis, that's an axis, that's an axis. This one is, that's an axis, that's an axis. This one's here and here. So I'm just drawing in the x and the y axes so you can see where they are. All right, if we look, I'm looking for a graph that's opening downwards. So I'm either going to have one of these two. The other two graphs are opening the wrong way. I need one that has shifted to the left. Well, these have both shifted to the left. This one has shifted to the left. So sorry, this one, the first one, has gone left from the origin. But it's gone 1, 2 spots to the left. This one over here, it's moved to the left from the origin, but it's only moved 1 to the left. And that's exactly what we wanted. So our first graph matches up with I, double I. Alright, we're going to try this with B, but we're going to go a little faster. So I have a positive 2, so that means I'm going to be opening upwards. So I'm going to be picking one of these two graphs. I have a negative 1, so that means that I've moved to the right. And if you look, both of these graphs have gone right. This first one has gone 1, 2 to the right. And this other one has gone 1 to the right. If you're wondering how I know how far they've moved, I'm looking at the vertex and I'm trying to figure out how far the vertex has moved to the left or the right from the origin, point 0, 0. For B, we wanted one that went 1 to the right, so that means our answer must be number 4, IV, because that's the only one that's gone 1 to the right. The next two should be pretty easy, because I'm now looking for one that's opening downwards. The only one that's left going downwards is I. And then I'm looking for one that's gone upwards, because there's no A value. If there's no A value, there's an invisible 1 there. So I'm looking for a graph that's opening upwards, and the other graph that's opening upwards is triple I. Okay, hopefully you come to class, because this is the end of this lesson, and you come to class with your practice booklet ready to work and ask questions. I suggest maybe practicing a little bit now, so maybe it sticks a little bit, and then come to class and try even more and see where you're stuck.